everyone. Welcome to week 4 of Pine Tree Programming. I'm Janice, and Allison and I are so excited to have you with us for another week of learning. This week, students are building an environmental dashboard using microbits. In this lesson, they'll combine sensory data, conditional logic, and button presses from the input menu to create a program with multiple modes. By the end, students will have a device that can respond to light, temperature, and even direction, while also learning how to organize their code in a really intentional way. To get started, let's begin with a quick discussion. Ask your students, what could you monitor with a microcontroller? This is a great way to connect the lesson to the real world. Students might mention things like temperature, light levels, or even tracking movement. From there, you'll introduce the idea that the microbit uses sensors to collect data. You'll have a look at all the sensor locations on the microbit, on the front and the back. And then you'll talk about data coming in as numbers and how we can use it to collect data. Those numbers are what students will use in their code to make decisions. In this lessons, students are working with 3 main sensors: light, temperature, and optionally the compass or pedometer, where they're using steps, which is something that they are familiar with using the accelerometer and the tilt or motion sensor. Each of these sensors gives a numeric value, and students will use if-else statements from the logic drawer to decide what to display based on those values that are coming into the sensor. So again, looping back to input and output as well. This is a really important concept to emphasize. The microbit doesn't understand light or temperature as it comes in. It only understands numbers. So students need to turn those numbers into true or false comparisons, like less than or greater than, in order to control what happens on the screen, or they'll use equals to as well. The entire program is built around a variable called mode, which controls what the microbit is displaying. Students will use button A to switch between modes. Each time they press it, the mode will increase, and once it goes past the last mode, it'll reset back to 0, meaning that we'll be able to have a certain number of modes that the students will be bouncing between for the different sensors. They'll also use button B to display the current mode. So when they press it, they'll see light or temp, or whichever bonus they choose, either comp for compass or step for pedometer. One of the biggest things to watch out for here is where students place their code. Both button A and B need to be in their own blocks, but not inside the forever block. They can't really fit anyway, so it should be quite easy for them to keep it separate. But there is one expression block, I believe in the input, where it says on button pressed. So make sure they're using the one that looks like the edge of the puzzle. Because if they're placed incorrectly, the program can flicker or behave unpredictably. The forever loop is where the dashboard actually runs. This loop is constantly checking the value of the mode variable and deciding what to display. So if mode is 0, the program runs the light sensor code because that's what we're going to program it as. If mode is 1, then it's going to run the temperature code, and that's the input we're going to put as well. If mode is 2, well, that's where the bonus or extension is. So students will either have a compass or a pedometer. And this is a great opportunity to reinforce how programs like this can be organized into sections, and how one variable, in this case mode, can control the behavior of the entire system. For students who choose the compass as their bonus, they'll use the compass heading to display north, east, south, or west. This is where students often need the most support. The trickiest part of North is because the compass wraps from 360 degrees back to zero. North actually falls into two ranges on either side of zero. So students need to use an or comparison block to check both conditions that are less than 45 degrees or greater than 315 degrees. If that or block is missing or it's built incorrectly, the compass usually won't work as expected. Another important step is to calibrate the compass. Students need to follow the prompts on the microbit before testing, or their readings won't be accurate. So for the second bonus option, students can choose to build a pedometer or a step tracker. Remember, the microbit has something called an accelerometer, so it can detect movements on the X, Y, and Z axis, like shaking, tilting, or even steps. You'll need to guide students to create a variable, this time called steps. Tell them to think of a variable like a scoreboard or a storage block for keeping track of total steps. Have them set the starting point. They'll use the on start block and then add the variable set steps to zero. This will make sure every time the program begins, the step count starts fresh. Now comes the fun part, motion detection. Students will add the on shake block. This tells the microbit, when you feel movement, do something. Tell your students they can think of each shake as a step, because when walking, the body actually creates motion, just like a shake. Now let's actually have the microbit count the steps. So inside the on shake block, they'll put change steps to 1. And then if they'd like to show the number, they can add show number. Otherwise, they could do button B press so that they can only see it when they press that. And then they can have a reset button for on button A pressed, and it'll reset it all the way back. So it kind of works like a stopwatch as well. This gives students another way to explore how the microbit can track real world data and turn it into something meaningful on the screen. As students are working, there are a few common issues you'll likely see. They may notice that steps are increasing rapidly. They could add a pause, like 100 milliseconds in their code. They may use set steps to 1 instead of change steps to 1 under shake block. If the compass always shows north, check that the or comparison block is set up correctly from the logic drawer and that the compass has been calibrated. If the program is flickering or changing too quickly, it's often because button code was placed inside the forever loop. And if the light or temperature values don't seem right, have students double check their comparison ranges and make sure they're using the correct sensor blocks, but also the comparison symbols like less than, greater than, or equal to. And encourage students to test one part at a time. This really helps with debugging and builds confidence. But another thing that we also noticed is when the sensors are working for temperature, it takes up to a minute for it to register the new temperature. To wrap up the lesson, give students time to explore their dashboards and see how they respond to different conditions. You might ask questions like, how could you use something like this in real life? Or what would you like to add next? How would you change it? This lesson brings together inputs, logic, outputs, and storage in a really meaningful way, and it gives students a chance to think like engineers, and they test and improve their work. Thanks so much for joining us for week 4 of Pine Tree Programming. We can't wait to see what your students create, and we hope that you'll share some examples with us.